अच्छा, uh, give me first this feedback that either my video is also displaying or not. And the second thing which I want to ask is that the lecture slides are displaying or not.
Both are displaying, sir.
Okay, that's good.
Everything is visible, sir.
Okay, okay. So I have started recording. Maybe you are seeing this message on your screens. So, so let's start. So this is basically the first introductory lecture of theory of automata and formal languages. Yesterday, I present an overview of the course that what are the contents that we have to study in this course and what is the URL or what is the portal on which the contents of the course would be available. So these are the things which I communicated to you yesterday. So now let's start, and this is the course, first lecture, and the title of our course is Theory of Automata and Formal Languages. So the question is, what is automata theory? So as we know that this is something about the machines. This is something, the study of machines, or we can say that this is the study of abstract machines. Here, the meaning of abstract is a little bit tricky, and here abstract means that something in your thoughts or something about which you have some idea like that. So in short, study of abstract machines is called theory of automata, or study of computing device, as you are seeing on the screen. So this is the normal definition for the theory of automata or automata theory. And we know that this word automata is a plural form of this word automaton. Automaton is a singular form, and automaton means machine, a computing device. And according to the definition, now we know that this machine or this computing device is not necessarily to be present in a physical form. So that's why it's called theory of automata, because normally you, whatever you do about the machines, you normally do in your thoughts or in your ideas. So there is no physical hardware is needed actually. So then the next point is very much fundamental question in computer science. And that question is, find out what different models of machines can do and cannot do. So this is the question, that what are the different things that a machine can perform and what are the different things that machines cannot perform, which means you have to identify the ability of the machines. This is the fundamental question. If some person asks you what is the ability of the machines, then you can think or you can find out the capability or the ability of the machines only if you have the knowledge of a theory of computation, or if you have a knowledge about this course. Then you can analyze that machines in this perspective. And that perspectives include two concepts. The first one is computability and the second one is complexity. Computability means that you have to think about in terms of computation, computation tendency, computation capability, and complexity. That is something you already maybe know from your another course, that is the course of analysis and algorithms, or fundamental of algorithms. You know the concept of complexity from that course. So here in complexity, normally you have to compute the space and time complexity, and there are other types of complexity also existing in literature, but as this is the very much fundamental, or this is the very much basic course of your undergraduate graduate studies, so you don't have to go into deep details about complexity. You only have to cover uh, space complexity, and the second one is time complexity in course of algorithms, not in theory of computation. You can also do the same thing in theory of computation, but here I am only explaining these two terms to you. So computability is something you have to, how some machine is computing some problem. So then you have to think about the statements or the steps involved in your problem solution. You have to think about those steps. So that is some kind, or that is some aspect of computability. So anyhow, in theory of computation, you normally discuss these two things: computability versus and complexity. So this is the person, or this is the scientist. You can say this is the pioneer of automata theory, and the name is very much famous, Alan Turing, and the period is mentioned. He's also called the father of computer science. So this is very much introductory things about this person, and he is an English mathematician, which means he lived in Britain maybe. So studied, and he studied abstract machines. Now you are understanding. He studied abstract machines, which means he studied some uh, theoretical machines, or he studied machines in his thoughts, or he studies machines in his ideas. Even this is one statement. He also builds some mechanical machine, but keep this thing aside. So he studied mainly these abstract machines, and he named those machines as Turing machines. And he invented these machines. We know that we invented these machines before the existence of computers. And I am sure that you already have heard the name of this Turing test. Is it true or not?
No, sir.
Anybody who knows something about Turing test?
सर ये देखिए उसके अंदर ये मिश्रण आता है
I am not listening your voice properly.
your
So
voice properly.
keep the mic near to you so that I can listen your voice clearly. Anybody who have the understanding of this Turing test?
Anybody who has
No any student in the class who has some knowledge about this Turing test? Okay, another question. Are you listening me clearly or not?
Yes, sir, we can listen clearly.
Okay, that's good. So Turing test is basically a test in which there is a computer behind the wall, and on the other side of the wall you can place, or you can introduce some human, and then that human has to interact with that computer via some application or via some software, and the person or the human who will communicate to that computer, he or she does not know that on the other side there is some machine. However, he or she will start communicating with the machine through software.
Sir, your voice is not clear.
I asked this question that my, for example, audio is clear or not, and mostly students already replied that they are listening me properly. But if some student is not listening me
Sir,
properly, then
your
might be the
voice
internet
is
issue.
not clear, sir.
So I am again asking, are you listening me properly?
No, sir, your
Yes,
voice
sir.
is not clear.
Yes, sir.
Yes, sir.
No, sir.
So only one student is not listening me properly. That might be the problem of his internet. So I don't have a solution for that. Rest of the students are listening. So that's good. That's fine for me. So Turing test, I am going back again to Turing test. So there is a wall. On one side, there is a computer. On another side, there is a human interacting with that machine or computer through some software. And if after some time, or if after passing, you can say 20 minutes or 25 minutes or 30 minutes, if you stop that conversation, and if you are doing that experiment, and if you ask that human that how do you feel, how do you feel, that were you communicating with a machine or a computer or a human, and if that person will answer in such a way that I don't know, maybe I am interacting with a human. I didn't feel anything. Uh, I didn't feel anything odd or like that. I didn't feel anything that I am communicating with a machine. If his or her feeling is like that, then it means that the application installed on your machine, or your machine is quite intelligent to communicate with the human, and the Turing test is now passed. This is called Turing test. And this test was built or invented by this Alan Turing. So this is just an experiment, theoretical experiment through which you can say that the software or the application which is running on the machine is quite intelligent. This is also a definition that we normally give to the students in other courses like artificial intelligence. So, did you study that course, artificial intelligence?
No, sir.
Okay, okay. So
No,
anyhow,
sir.
now I hope that you have the understanding of this Turing test. Is it okay or not?
Okay,
Okay,
sir.
sir.
It's okay.
Okay, good.
No,
Now,
sir.
no, sir. What do what did you not
No,
understand
no, sir.
in our previous discussion? Some student is saying that I didn't understand the definition of this Turing test. There was a female voice actually, and there was a male voice also. So very speedy or very quick review about the definition of the Turing test again. So there is a wall. On one side there is a machine, on other side there is a human, and human is interacting with that machine. After 20, 25, or 30 minutes, you stop that experiment, and then you ask that human, did you feel that you have communicated with a machine or a human? And if that person will answer that I didn't feel anything, maybe I am communicating with a human, so then it means that the Turing test is passed, and your software which is running on that machine is quite intelligent to in communication with a human. So this is called Turing test, that was invented by this Alan Turing. Okay.
Yes.
So now I am moving towards the next slide, which is just, you can say, the history. I have a very common statement for this kind of information, that this is just a news for you. So it is only a history of theory of computation or theory of automata. What happened in 1930s? what happened in 1940s to 50s, and similarly 69 and 70 like that. So in 30s, Alan Turing, he studied Turing machines and he presented a concept of decidability. Decidability means the capability of deciding about some problem, and this capability is of the machines. So the machine's capability of deciding something about the problem, this is called decidability. And the second one is halting problem, that if you give some problem to some machine, then where the machine will halt. So this is another deep discussion, but this is called halting problem. So these are the things which were going on in 30s. And in 40 to 50s, finite automata came on the sky, and the people were thinking about this finite automata. And there was a person whose name was Noam Chomsky, and he presented his hierarchy for formal languages. What are the formal languages? These programming languages are also formal languages, or you can say uh, context-free languages, remunerable languages, regular languages. These are also formal languages. So this person has presented some theory, and he presented a hierarchy of these formal languages that is called Chomsky hierarchy. So this was the discussion which were going on in 40s to 50s. And similarly, you can read by yourself. There is another person, the name was Cook, who introduces intractable problems or NP hard problems. Maybe you have heard about polynomial and non-polynomial problems. So this NP means non-polynomial. So only P means polynomial. So the polynomial problems are those problems, the complexity of those problems can be, you can say, can be solved, or can be, the problem can be solved in polynomial time. Polynomial is what? X power, X raised power 3, X raised power 4. This is polynomial. So this is a problem's complexity. If it is in a polynomial form, then that problem is a polynomial problem. If some problem whose complexity is not polynomial, then it is NP hard. Then it means its complexity is non-polynomial, and maybe, and these are the problems. There are many problems which are still unsolved, and people are doing research on those problems, and they are not getting solution for those problems. So that's why this is the category of NP hard problem, the problem which don't have any solution yet. So once again, are you listening my voice? Audio is clear?
Yes, sir.
Okay,
Yes,
good.
sir.
And then there is the era of 70s, when this era is called modern computer science era. And in this era, compilers were introduced, parsers were introduced, and the people were busy in computational power of the problems, or the people were busy in thinking about computational ability of the models, or people were busy in concluding complexity of problems, are like that. So this is just a news. You only have to read this literature so that you can understand that there are different things in different periods which were going on in the history. And now this is simply, you can say, the starting of your course. And uh, and it, this slide is giving some concept about languages and grammars. And the first thing that you are seeing here is a definition of an alphabet. What is an alphabet? If you think in terms of programming languages, then every character is an alphabet. So the same concept here. So the same concept here. This 0 is an alphabet. This 1 is an alphabet. So, but this 0 comma 1 in curly braces is something, a set of alphabets. So if you will see this word alphabet in theory of programming, in theory of formal languages or in theory of automata, then you can say an alphabet is normally a set of symbols, and these symbols can be any A, B, C, X, Y, Z, 0, 1, whatever. And these curly brackets gives us another idea that this is a set. So this is the simple definition of a set that you already have studied in mathematics. So nothing different. And there is another word you will study in this course, that is sentences. So sentences are simply strings. Sentences would be simply strings of symbols, or strings of alphabets, you can say, as you are seeing here. So this 0 is one string, 1 is another string, 0, 0 is another string, 0, 1 are 1, 0. So these are the different strings given here for your understanding. And sentences are strings of symbols. For example, if you have a sentence in English language, then in that sentence, we normally have the words, we normally have the strings written in alphabets from A to Z, or you can say. So words normally exist in a sentence. So sentence is normally a collection of strings. Khalas. So this is the simple definition. So what is language? Language is a set of sentences. So if you will hear this word language in this course, then it means that it is a set of sentences like this. This L is a language, and it is equal to, between curly braces, so 0, 0, 0. So maybe this is 1. So these are basically strings. So set of sentences. You can also consider it, maybe we have a sentence here. So if it is a sentence, then this is one sentence, second sentence, third, fourth. So collection of sentences is called language. Collection of strings is called sentence. So these definitions are quite simple, but I think I am going very much uh, in detail. So if I am going in a very much detail, then there is a probability that might be you didn't or you don't pick the point actually what I want to convey. So alphabet is simply a character. Sentence is simply a collection of strings. Language is simply a collection of sentences, nothing else. And grammar is a finite. It is not infinite. It is finite, limited. Is a finite list of rules. Rules also means productions. I am sure that you may have already know something about the word production or the rules in some other course. So this is one production. S goes to 0A, this is one production. A goes to 1A, this is another production. This production is also known as a rule. So this diagram consists of different rules, 1, 2, 3, 4, 5, 6, 6 rules, or you can say this diagram consists of 6 productions. And this diagram is a diagram of a grammar. So now the definition of grammar is a finite list of rules defining some language or defining a language. So this is the definition of grammar. So grammar is what? Grammar is a finite list of productions or rules, and those rules are defining some kind of a language. So on the right side, you will see proper definitions. Language. What is language? A language is a collection of sentences. and those sentences will contain of finite length, sentences of finite length. Language is a collection of sentences of finite length, all constructed from a finite alphabet of symbols. So by collecting these concepts, you will have a definition for languages. So, so I am stopping this lecture here, and maybe I am initiating it again because the time is going to be ended now. It's okay?
Yes, sir.